chart for every piece. So if I am looking at that first piece, so if I go to plug in, what do I absolutely have to plug in on that one? -3 and +1 because I have 2 endpoints. And then you can do as many points in the middle as you want. I'll do a -1. You can do more if you want. At -3, would that be an open or a closed circle? And how do we know it? And 1 would be open because it didn't have an equal to. All right, so if we put in -3, the opposite of -3 would be 3 plus 1 is 4. If I put in -1, the opposite of -1 is 1 plus 1 is 2. If I put in a 1, the opposite of 1 is -1 plus 1 is 0. So we have -3, 4, -1, 2, +1, 0 was open. This had 2 endpoints, so when you draw it, it's just that little line segment. The second piece, that was a little harder. What x can we plug in? 1, and that's the only x we can plug in. What do we get out when we plug that in? So how do we plot that? 1, 2, and that's the only x value it works for, so it's just a single dot on my graph. Then the next one, x squared if x is greater than 1. So we have to put in 1, will be open, and then we need things larger, so maybe a 2 and a 3. 1 squared is 1. 2 squared, 3 squared. So 1, 1 is open. 2, 4, 3, 9. How do we graph that? What is this? Parabola. So it's kind of hard, I know, to curve just this little section, but that's what we're doing. Oops. So we have this curve here. All right. Are there questions there? So notice, would this pass the vertical line test? Yes. I have 3 points when x is 1, but 2 of them are open circles, so we're okay. So now if we go to answer all these questions. The first one, we could do whether we had the graph or not. If I ask you to find f of 0, function notation, this was on our last quiz. That means when x is 0, what is y? So we could look at our graph when x was 0, y is 1. We could also look at our equations. If x is 0, which of these 3 pieces would we be using? The top one, because 0 is between -3 and 1. And so if you put it in there, the opposite of 0 plus 1 is 1. So there's a few on the homework when you flipped the page last night that people were asking about, and asking, do I put it into every piece or what? No, you have to find the one that fits your domain and look at that one. If I ask for f of 1, if x is 1, which of these pieces would we plug it into? Second one, and we just get out 2. If you look at your graph, when x is 1, which are y 2? Yeah. F of 2. If x is 2, which piece are we putting it into? Third one. 2 squared is 4. If you look at your graph, 2, 4. That was our point. So we can check ourselves there. All right, domain. Let's look at domain and range from our graph. What is the domain here? Where does this start? -3. Okay, the blue piece ends when x is 1, but I have a red dot there. Then the red dot's over, but the green one picks up and goes forever, so it would be 3 to infinity. Okay, the range. What is the lowest point on this graph? 0. We don't hit it. It's an open circle, so that's a parenthesis. Okay, that blue one hits everything up to here. The green hits everything after that, so it would just be 0 to infinity. Is this graph continuous? No, we have breaks in it. Now we could give intervals. We could say it's continuous from -3 to 1 and from 1 to infinity. But overall, this is not a continuous function. All right, we struggled with that one. Why don't you guys try another? See if you can figure out what this graph would look like. It's a little bit different.
Okay. So 2x
When x does not equal 0. So what did you plug in? Any number but 0? Okay. Okay. Why did you put in 0? Okay, we still need to put it, but what would be true? It would be an open circle at that point. So we still need to put it in so we get an idea of what our graph looks like, but it will be open. So if I put in -2, I get -4. -1 gives me -2. 1 gives me +2. 2, 4, 0, 0. So if I graph these, -2, -4, -1, -2, 0, 0, open. 1, 2, 2, 4. Isn't this just a line? Y-intercept of 0, slope of 2. So if you recognize that, you didn't really have to do the t-chart. But this is true for everything except 0. That means this extends forever both ways. And then my second rule is 1 if x equals 0. How do we graph that? It's a point. When x is 0, your y is 1. Does this pass the vertical line test? Yeah, you have a line with an open circle and then a point elsewhere. Okay, so if I wanted f of 0, which of the two rules did we plug 0 into? Or which one has 0 in its domain? The bottom one, and we would get out 1. If I say f of 1, which one are we plugging it into? The top, and 1 times 2 is 2. If we put f of 2, we get out 4. What is the domain of this graph? What is the range? Because we never hit a y value of 0. We only had an open circle there. Last question. Was this continuous? No, because if I'm drawing it, I can get to my open circle, then I have to pick up my pencil and make my dot, and then keep going. So it's not a continuous function. These piecewise functions are only continuous if the two parts match up. All right, I might throw another one of these up on the board in a minute because I think some of us are still having a little trouble graphing them. That's okay, I'll give you another one to practice. But I do want to talk about one final type of function, the greatest integer. And I'm sorry, I tried to type it and it just doesn't type correctly. It's like a double barred x. Do you guys remember what the greatest integer function is? Did you do this one in Algebra 2? Okay. All right. So a greatest integer function says you can only get out integer values. So x, you can plug in any x value, it gives you an integer back. When I say integers, what are those? Positive and negative whole numbers. -2, -1, 0, 1, 2, 3. The second rule is you can't get out anything bigger than what you put in. All right, so for instance, if I put in 0, 0 is an integer. So the greatest integer function doesn't change it. The greatest integer of 0 is still 0. Okay, but if I put in 0.5, I can't get out 0.5 because it is not an integer. So 0.5 falls between which two integers? 0 and 1. Which one's smaller? 0, because I can't get 1 out since 1 is bigger than 0.5. If I put in 0.9, what is the greatest integer of 0.9? Still 0, because it still falls between 0 and 1. You have to give me the smaller number, so we get out 0. When I put in 1, what's the greatest integer of 1? 1, because it's an integer. Okay, on my graph, I am going to kind of change this scale a little bit. I'm not going to count by ones, because with all my decimals, this is just too hard. Okay, so far, I have that if I put in 0, I get out 0. If I put in a half, I get out 0. If I put in 0.9, I get out 0. But if I put in 1, I get out 1. Can I count by, can I stretch out my y-axis a little bit too? Does that bother anybody? So when I put in 1, I get out 1. What if I were putting in 0.999? What would I get out? 0. So I am down here. I am getting out zeros up until the point when I plug in 1. But you can't tell me the closest I can get to 1, because I could always get closer, right? So what we have to put down here is an open circle. Out. 1, 0. Because I'm down here up until the point when I plug in 1. So now if I'm plugging in 1.5, what do I get out? 1. If I put in 1.9, what do I get out? If I put in 2, what do we get out? So if I put in 1.5, I'm still at 1. If I put in 1.9, I'm still at 1. But when I put in 2, I jump up to 2. So what do I have to end this piece with? An open circle. So we're going to be here up until we put in 2, and then that's open. So then we're going to be getting out 2 up until I plug in 3, and then when I plug in 3, we'll get out 3. Okay? If I put in negatives, let's make sure it works the same way. If I put in negative 1, what do we get out? Is negative 1 an integer? Yep, so negative 1 would give me negative 1. Okay, if I put in negative 0.5, negative 0.5 falls between negative 1 and 0. Which is smaller? Negative 1. If I put in negative 0.9, what am I going to get out? Negative 1. Okay, so we're down here up until the point when we put in 0 and then we jumped up. So now we can kind of see the pattern. These are like little stair steps. They have a closed circle on the left, an open circle on the right, and then it jumps up. Okay, and it just keeps going. So this is called the greatest integer function. Your range is only the integers. My domain, I can plug in any x, but my range, the answers I get out are only integers. And in real life, this is something like postage. When you go to mail a letter, if your package or if your envelope weighs less than a certain number of ounces, don't you only have to buy 1 stamp? So for everything from 0 up until that amount, you buy 1 stamp. And then if you go over, there's a range. If it falls in this window, you need a 2nd stamp. If it's in this window, you need a 3rd stamp. That's an example of the greatest integer type function. All right. If I asked you to write the domain and range for this, so domain is everything. The range, I told you it's all the integers. Do you guys know what the shorthand for integers is? Just the simplest? It's that's rational numbers is Q. integers is that double barred Z. Remember, real numbers is the double barred R, Q is your rational, Z is the integers. So let's graph a variation of these. We're not going to graph a ton of them, but it is good practice. So this is the greatest integer of x plus 2. And I apologize, the way it types funny, just Smart Notebook doesn't have a good equation editor, so it's all I can do. So if I want to type this, this is one where it's probably easiest just to make a table of values. Now we know the pattern, so once we get the first step, we can kind of extend it from there. We just need to figure out what one step looks like. So give me a nice integer value to start with. 1. If you put in 1, you have the greatest integer of 3, which would be 3. Now, don't only plug in like 1, 2, 3 on this. That's not going to help. The greatest integer, we have to put in some decimals. So if I put in 1.5, 1.5 plus 2 is 3.5. What's the greatest integer of 3.5? Okay, if I put in 1.9, I get the greatest integer of 3.9, which is 3. If I put in a 2, I get the greatest integer of 4, which is 4. So let's see what this looks like. So when I put in 1, I got 3 out exactly. That was the beginning of a step. When I put in 1.5, I'm still getting out 3. When I put in 1.9, I'm still getting out 3. But when I put in 2, I got a 4 out exactly. So that's where the next step begins. So we put an open circle underneath that to finish the step we're on, and then it jumps up. My general rule, I'm going to tell you, I want at least 3 steps on your graph. So if you need to keep plugging in values, you can, or you can extend it. So now we can see, okay, my step is 1 long, and then I jump up 1. So I'm going to stay on this step between 2 to 3, and when I put in 3, what am I going to get out? 5. I'll jump up to the next one. And if you go the other way, we would just have to go down a step. Okay, so you can extend this pattern as much as you like. What I usually ask is that at the end, you just put ... on each end. Either extend it all the way to the end of the graph paper, or just put those dots to show this pattern continues. It doesn't just stop here, it would keep going. Let's look at this. So an express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph it on the interval 0 to 6. So I'm not asking you to write an equation. We're just drawing a graph. My interval is 0 to 6, so my x-axis is just going to go up to 6. Can I have a package that truly weighs absolutely nothing? No. That's why my interval starts with a parenthesis. So my first point, if I put in 0, it's going to be an open circle when I graph this. Now it tells me my starting cost is $20 for anything up to 2 pounds. So that means if it weighs 1/4 of a pound, we pay $20. If it weighs 1/2 a pound, we pay $20. If it weighs 2 pounds, we pay $20. Okay. So, we are up here at 20. If it's 1/2 a pound, if it's 1 pound, if it's 1 1/2 pounds, even if it's 2 pounds. And And where would I put an open circle? At 0, 20. So this starts with an open circle, and then if we have this horizontal line segment, because we're paying that flat rate. But as soon as my package goes over 2 pounds, even if it's just an ounce over, what happens to my cost? Goes up $2. So as soon as I cross past that 2, I'm now paying $22. What should I begin this step with? An open, because can you give me the first number bigger than 20? No. Okay, and we are going to stay there for each additional pound. So even if my package weighs 3 pounds exactly, I'm still paying that $22. But as soon as I go over my 3 pounds, what happens? It's going to go up to 24. I'm going to stay there until I get to 4 pounds. And then after 4 pounds, it would go up to 6 until I get to 5 pounds. Then after 5 pounds, it goes up to 28 until we get to 6 pounds. Is that okay? I want to look at just a couple last things. X equals y squared. If I asked you to graph that, what would you do? Okay, you can get y by itself, or if you didn't want to do that, could you make a t-chart from this? Would you plug in your numbers for your x or for your y? Yeah, so if you didn't want to mess with the square root, you can do that. We just put in your numbers for your y. So let's try like some -2, -1, 0, 1, 2. So sometimes you don't always have to plug in for x. All right, if I put in -2, -2 squared is 4. -1 squared, 0 squared, 1 squared, 2 squared. So if I look at this graph, 4, -2, 1, -1, 0, 0, 1, 2, 4. What is this? Sideways parabola. Is it a function? No. Why? Doesn't pass the vertical line test. Remember, the function, any vertical line can only hit it once. Okay, I'm going to let you work on your homework, and then maybe at the end of class, I might come back and do a bonus problem. I didn't put any on